@NCERT video book welcomes you. In this channel, you will see explanation and solution of NCERT books. For this, you have to visit the channel, then go to playlist and see the chapter you want to learn. Today we will be studying Social Science textbook for grade 6, Exploring Society, India and Beyond. Theme A: India and the World, Land and the People. Chapter 1: Locating Places on the Earth. Let's start Chapter 1: Locating Places on the Earth. The globe of the Earth stands in space made up of water, earth, fire and air and is spherical. It is surrounded by all creatures, terrestrial as well as aquatic. Aryabhat, about 500 CE. Let's understand what is the meaning of CE. For this, we will be moving to Chapter 4. Here we will be understanding the meaning of Common Era or CE, also known as AD or Anno Domini. AD stands for Anno Domini. And we will also understand the meaning of BC or Before Christ, also known as Before Common Era or BCE. For this, we will be reading this page. In the West, the conventional year for Jesus Christ's birth has generally been taken to be the starting point of this calendar. Years are counted forward from this point and used to be marked with AD, an abbreviation for a Latin phrase that refers to the years after Jesus' birth. However, this is now called the Common Era or CE across the world. For example, 1947, the year India gained independence, can be written as 1947 AD, sometimes AD 1947 or 1947 CE. Similarly, the years before the conventional date for the birth of Jesus are counted backward and used to be marked with BC or Before Christ. They are now called Before Common Era or BCE. For example, 560 BCE is an approximate year of birth of Gautam Buddha, whom we will meet in Chapter 7. Can you calculate how many years ago that was? Let's explore. Such calculations are simple, but there is a catch. In the Gregorian calendar, there is no year 0. The year 1 CE follows immediately the year 1 BCE. Draw a simple timeline marking every year from 2 BCE to 2 CE. You will see that because of the absence of a year 0, only 3 years have passed between those two dates. On a number line between -2 and 2, there is a gap of 4. 1, 2, 3, 4. If you make a timeline like this from 2 BCE to 2 CE, you will note that there is no year 0. The gap between 2 BCE and 2 CE is 3 years. 1, 2, and 3. So to calculate the number of years between a BCE date and a CE date, you should add them but subtract 1. In above case, 2 plus 2 minus 1 is equal to 3. Practice a few examples with your classmates. For example, to return to the question about the Buddha, suppose we are now in the year 2024 CE. Then the Buddha was born 560 plus 2024 minus 1 is equal to 2583 years ago. Let's move to chapter 1. The big questions. 1. What is a map and how do we use it? What are its main components? You can write like this. A map is a visual representation or a drawing of an area drawn on a flat surface according to a scale. It can be used to represent a small area, a village or a town, etc., a bigger area, a district or a state, or a very large area like India or even the whole world. The main components of the maps are distance, directions, and symbols. 2. What are the coordinates? How can latitude and longitude be used to mark any location on the earth? A set of values or items used to indicate the exact position of a place or an object are known as coordinates. For instance, latitude and longitude are two coordinates used to mark the location of a place on earth. Latitude measures the distance of a place north to south of the equator, ranging from 0 degree at the equator to 90 degree at the poles. And longitude measures the distance of a place east or west of the prime meridian, ranging from 0 degree to 180 degree east and 0 degree to 180 degree west. 3. How are local time and standard time related to the longitude? You can write like this. Local time is determined by the position of the sun in the sky at a particular longitude. So, places along the same longitude generally share the same local time. However, in regions that span multiple longitudes, standard times are used. Standard time is a uniform time observed across a specific region or time zone and is typically based on the local time at the region's central meridian. Imagine that you are visiting a city for the first time. How would you find the places you want to visit? You might ask a local person for help, or you might look at a map of the city. In previous grades, you learned a little about maps, and in this chapter, we will study them in more detail. Let us play a game. Examine the map of this small city, figure 1.1. Figure 1.1, a map of an imaginary small city. You can see in central region there is a hospital with a red cross sign. There is a school. There is a market, museum, bank, Nagar Panchayat, apartments, railway station, public garden, roads, and water bodies. Imagine that you just got off a train at the railway station and you want to visit the bank marked on the map. Which way would you go? Are there other possible ways? Can you locate the public garden, the school and the museum? If you want to proceed from the bank to the market, which way will you go? This is where a map comes in handy. You can see school here, museum here and public garden here. If you want to go from railway station to the bank, then you can follow this path, or you can go via Nagar Panchayat, or you can follow this route. Similarly, if you want to go to market from bank, then you can follow this path. You can see 4 arrows in the above right corner. N stands for north, E stands for east, S stands for south and W stands for west. The 4 cardinal directions are NEWS, that means north, east, west, south. A map is a treasure guide. It shows you where things are and how to get to them. Notice the 4 arrows in the top right corner of the map. We will soon see how they point to some specific directions and make maps even more helpful. Let's explore. On the map in figure 1.1 given on page 8, 1. Mark the hospital. 2. What is the meaning of the blue colored areas? 3. Which is farther away from the railway station, the school, the Nagar Panchayat or the public garden? You can see hospital in the central region of the map having red cross sign. Blue colored areas signify water bodies such as lake, ponds, rivers, streams, etc. The farthest place from the railway station is public garden. You can write the answers like this. The hospital is in the central portion of the figure with a red cross sign. The blue color areas represent water bodies. Third, the public garden. As a class activity, form groups of 3 or 4 students each. Let each group try to draw a map of your school and some of the streets or roads that lead to it, and a few neighboring buildings. At the end, compare all the maps and discuss. You can try doing that. A map and its components. From this simple example, we understand that a map is a representation or a drawing of some area. It may be a small area, a village, a town, etc. A bigger area, say your district or state, or a very large area like India or even the whole world. In a map, you look at the surface as if you are viewing it from the top. An atlas is a book or collection of maps. As you will discover, there are several kinds of maps. Physical maps, which mainly show some natural features such as mountains, oceans and rivers. See an example in figure 5.2 in this textbook. Let's move to chapter 5 and see figure 5.2. Figure 5.2, a physical map of the Indian subcontinent with some of its rivers. You can see a physical map here. This map shows the Indian subcontinent with some of its physical features such as rivers, mountains, plateaus and plains. Let's move to Chapter 1. Political maps, which show details of countries or states, boundaries, cities, etc. For instance, a map of India with all its states, union territories, and their capitals. Thematic maps with a specific kind of information. Examples include Figure 6.3 and Figure 8.1 in this textbook. Let's move to Chapter 6 and see Figure 6.3. Figure 6.3. Map of some of the main settlements of the Indus-Varsity civilization. Notice the natural boundaries formed by the mountain ranges in brown color. This is a thematic map of the main settlements of the Indus-Saraswati civilization. Let's move to Chapter 8 and see Figure 8.1. Figure 8.1. A few examples of cereals and pulses from different regions of India. This is another thematic map showing different types of cereals and pulses from different regions of India. Let's move to Chapter 1. In addition, there are three important components of maps that are distance, direction, and symbols. You have already experienced the first two while navigating the map in Figure 1.1. Let us now define them more precisely. Have you ever wondered how a huge place can fit on a small piece of paper? It is all thanks to the map's scale. Let us go back to our map of a small city, Figure 1.1. Each centimeter on the map, as printed here, represents a certain distance on the ground. Let us suppose it is 500 meters. We say that the scale is 1 centimeter is equal to 500 meters. Now turn to the map of India in Figure 5.2 in Chapter 5 of this textbook. The scale is represented in the bottom left corner by a ruler with 500 written above its length and km on its side. It simply means that this ruler, which measures 2.5 cm in the printed map, corresponds to 500 kilometers on the ground. Suppose in a map it is written like this. This length is equal to 500 kilometer. In Figure 5.2, this length is 2.5 centimeter on paper. That means 2.5 centimeter on paper is equal to 500 kilometers on ground, or 1 centimeter on paper is equal to 500 upon 2.5 kilometers on the ground, or 1 centimeter on paper is equal to 200 kilometers on the ground. Let's move to Chapter 5 and see Figure 5.2. In Figure 5.2, you can see a scale here. Above the scale, it is written 500. On the side, it is written kilometer. This length on the map is equal to 2.5 centimeter. That means the scale is 2.5 centimeter is equal to 500 kilometers on the ground. Let's move to Chapter 1. Sometimes scales are written in ratios like this: 1 is to 2 crores. That means 1 centimeter on the paper or map is equal to 2 crore centimeters on the ground. I have written here 2 crores. 2 crores is equal to 2 lakh meters or 200 kilometers. That means 1 centimeter on the map is equal to 200 kilometer on the ground. The ratio scale is same as this equation scale. So the actual distance between the 2 points represented on the map depends on the scale that the map is using. Let's explore. Draw a simple map of a school's playground. Let us assume it is a rectangle, 40 meter in length and 30 meter in width. Draw it precisely with your ruler on a scale of 1 centimeter is equal to 10 meters. You can draw like this. The length of the rectangle is 4 centimeter and width is 3 centimeters. Since the scale is 1 centimeter is equal to 10 meter, that means the length is 40 meters on the ground and width is 30 meters. Now measure the diagonal of the rectangle. How many centimeters do you get? Using the scale, calculate the real length of the playground's diagonal in meters. If you measure from this corner to this corner, that is the distance between the opposite corners, you will get 5 centimeters. That means 5 centimeter on the map is equal to 50 meters on the ground. You can write the answer like this. Length of the playground's diagonal on the map is equal to 5 centimeter. Actual length of the playground's diagonal on the ground is equal to 5 into 10 is equal to 50 meters. Let us return to the 4 arrows at the top right of the small city's map. They point to 4 directions, which are north at the top and moving clockwise east, south and west. These are called the cardinal directions, also cardinal points. Other than these, intermediate directions are also used, such as northeast NE, southeast SE, southwest SW and northwest NW. Most maps simply have an arrow marked with the letter N, which points to the north direction. N stands for north, E for east, S for south, W for west. These are cardinal directions. Intermediate directions are also there, such as northeast NE, southeast SE, southwest SW, northwest NW. Let's explore. Consider the map of the small city again. Identify the correct and incorrect statements in the list below. 1. The market is north of the hospital. You can see here the market is in the south of the hospital. So this statement is incorrect. 2. The museum is southeast of the bank. The museum is south of the bank, not southeast. So this statement is incorrect. 3. The railway station is northwest of the hospital. The railway station is northwest of the hospital. This statement is correct. 4. The lake is northwest of the apartment blocks. The lake is southwest of the apartment blocks. So, the statement given is incorrect. Taking your school as the starting point, do you know approximately in which cardinal direction your home is located? Discuss with your teacher and your parents. You can try doing that. Symbols are another important component of maps. Our map has small drawings of actual buildings and a few other elements, but there would not be enough space on the map of a large city or a country to draw them all. Instead, a symbol is used to represent these features. Symbols for different kinds of buildings, for instance, a railway station, a school, a post office, for roads and railway lines, and for natural elements such as a river, a pond, or a forest. In that way, numerous details can be shown in the limited space available on a map. To make maps more easily understood by a variety of users, map makers use specific symbols. Different countries use different sets of symbols. The Survey of India, a government body, has fixed a set of symbols for maps of India or parts of India. A small selection of them is shown in figure 1.2 on page 12. Figure 1.2, a selection of symbols commonly used in maps. Railway line, broad gauge, meter gauge, railway station. Roads, metalled, unmetalled. Boundary, international, state, district. River, well, tank, canal, bridge. Temple, church, mosque, chhatri. Post office, post and telegraph office, police station. Settlement, graveyard. Trees, grass. Let's explore. Draw a rough map of your locality or your village, including your home, school, and a few other important landmarks. Show the cardinal directions and use a few of the symbols shown in figure 1.2 on page 12 to mark some important features. Mapping the Earth. Mapping the Earth is a little more difficult because our planet is not a flat surface. It nearly has the shape of a sphere. We say nearly because it is not a perfect sphere, but is slightly flattened at the poles. However, in practice, we will consider it to be spherical. Representing a sphere accurately on a flat sheet of paper is not possible. To understand why, peel an orange in such a way that you have just 3 or 4 large pieces of the skin. Then try and flatten them on a table. You will see that you cannot do it without tearing it at the edges. Now consider a globe, which is a sphere on which a map is drawn. This may be a map of the Earth, the Moon, the planet Mars, the stars and constellations in the sky, etc. The physical objects like the one shown in the drawing on the next page is a sphere that is generally made of metal, plastic or cardboard. You can see a globe here representing the earth. It is generally made of metal, plastic or cardboard. Here we will study the globe representing the earth's geography. Because the globe and the earth have the same spherical shape, a globe will better represent the geography of the earth than a flat map. Let us now explore some of its features. A. Understanding coordinates. Imagine a big market in a city or town with neat rows of shops all the same size. You want to meet a friend at the stationery shop inside the market, but your friend does not know where the shop is. So, you would get directions like meet me at 6 pm at the 7th shop in the 5th row from the entrance. This will allow your friend to precisely determine your location. Now, consider a chessboard. To record moves by advanced players, letters are placed alongside the main pieces from A to H, see the image, and numbers from 1 to 8 in between the two sides. This simple system allows players to mark each square and record every move. Here, the white side has just opened the game by moving the queen's pawn 2 squares forward, a very common opening. So, the pawn is said to have moved from d2 to d4, from d2 to d4. You can see d here and 2 here. So, this square is named d2 and 4 is here. So, this square is named d4. Let's explore. Using the same terms, write down your move if you play back and respond with the same move. If you move the black queen's pawn from this location to this location, then you have moved from d7 to d5, d7 to d5. The system used in these two examples may be called a system of coordinates. Thanks to their two coordinates, the stationary shop as well as the chess square on the chessboard can be precisely determined. A similar system of coordinates is used in the world of maps to determine the location of any place on a map. Let us see how this system works. B. Latitudes. Let us return to the globe. It is easy to identify the North Pole and the South Pole on it. Rotate the globe. While it rotates, the fixed points at the top and bottom are the two poles. Halfway between them is the equator. Note the circle marking it. See figure 1.3. You can see North Pole here, and on the opposite side there will be South Pole. If this sphere represents the earth and this is the middle line or middle circle around the earth, also called equator, then from the center the line joining the equator will make 0 degree. So equator is called 0 degree latitude. And from this line North Pole makes 90 degree, so called 90 degree north. You can see here. Similarly, the South Pole will make 90 degree, so called 90 degree south. Similarly, there are other parallels of latitudes or circles parallel to equator. Their angle from the center is named as 30 degree north, 60 degree north, etc. Similarly, those in the southern hemisphere are numbered as 30 degree south, 60 degree south, etc. You can see parallel of latitude here 30 degree north, 60 degree north here, similarly 30 degree south here. These are called parallels of latitude. Equator is largest parallel of latitude, dividing the earth into two equal parts horizontally. Figure 1.3. This globe shows both parallels of latitude and meridians of longitudes. Imagine that you stand on the equator and travel towards one of the poles. Your distance from the equator increases. Latitude measures this distance from the equator. At any point of this travel, you can draw an imaginary line that runs east and west parallel to the equator. Such a line is called a parallel of latitude and it draws a circle around the earth. Again, it is easy to note on the globe that the largest circle is the equator, while the circles marked by the parallels of latitude grow smaller as we move northward or southward. Figure 1.3. Latitudes are expressed in degrees. By convention, the equator is latitude 0 or 0 degree, while the latitudes of the two poles are 90 degree north and 90 degree south respectively. This is noted 90 degree north and 90 degree south. There is a connection between latitude and climate. Around the equator, the climate is generally hot. It is also called torrid. As you travel away from the equator towards one of the two poles, in other words, as your latitude increases, the climate becomes more moderate or temperate. And closer to the north or south pole, the climate grows colder or frigid. You will learn in science why this is so and also why we experience different seasons in the course of a year. See longitudes. Imagine now that you travel from the North Pole to the South Pole by the shortest possible line. Observe the globe. You will see that instead of passing through Europe and Africa, you could just as well pass through Asia. The distance would be the same. These lines are called meridians of longitude. Figure 1.3. They are all half circles running from one pole to the other. You can see half circles connecting North Pole to South Pole vertically. The reference circle is prime meridian or said as Greenwich meridian or 0 degree longitude. There are circles in the east of prime meridian known by 30 degree east, 60 degree east and so on, such as 90 degree east. Similarly, there are longitudes that are in the western side of prime meridian such as 30 degree west, 60 degree west and so on. The areas closer to the equator experience hotter climate called torrid climate. Similarly, those slightly away experience slightly less temperature called temperate climate. And near the poles, either north or south, the climate is colder or frigid. You can see here there is a meridian that is opposite to the prime meridian, also called 180-degree longitude. The letter W or E is omitted because 180-degree east is same as 180-degree west. So the letter E and W are omitted. So the meridian opposite to prime meridian or Greenwich meridian is called 180-degree longitude. Later we will see this is approximately closer to the international date line. You will also learn in science that the earth spins on its axis. To put it simply, let's place a desk lamp a little away from our globe, focused on it, and imagine that this is the sun illuminating the earth, slowly rotating the globe eastward. We can note that for some places on the earth it is morning, while for others it is midday, evening or night. When it is breakfast time in one country, it is lunch time in another, and in a third country, people are fast asleep. That is why, by measuring the longitude of a place, we will also be measuring the time at that place. Let us see how. To measure longitudes, we need to define a reference point called the prime meridian. See figure 1.3 on page 15. It is also called Greenwich meridian because in the year 1884, some nations decided that the meridian passing through Greenwich, an area of London in England, would become the international standard for the prime meridian. It is marked as 0-degree longitude. Just as latitude is a measure of the distance from the equator if you travel towards one of the poles, longitude is a measure of the distance from the prime meridian if you travel along the equator. Longitude too is measured in degrees. Westward or eastward, it increases in values from 0 degree to 180 degree with the letter W or E added. For instance, using round figures, New York's longitude is 74 degree west, while Delhi's is 77 degree east and Tokyo's is 140 degree east. Don't miss out. As you can see on the globe of meridians of longitudes 180 degree west and 180 degree east are the same longitude. So this longitude is noted 180 degree, omitting the letter W or E. Latitude and longitude together are the two coordinates of a place. With them, you are now able to locate any place on earth. You can now understand a statement such as Delhi lies 29 degree north latitude and 77 degree east longitude. These values are rounded off, not exact. Figure 1.3 on page 15 shows the parallels of latitude and meridians of longitude together on the globe as blue lines. All these lines together constitute a grid for the globe. They are also called grid lines. You have seen that meridians of longitudes and parallels of latitude form grids, so-called grid lines. You have studied Cartesian coordinates in mathematics, x-axis, y-axis, origin 0, 0. You can locate any point on this Cartesian plane. Similarly, any point on the earth can be located based on its latitudinal and longitudinal values. Let's explore. If the globe or atlas in your class has well marked latitudes and longitudes, try to note down approximate values for the latitude and longitude of 1 Mumbai, 2 Kolkata, 3 Singapore, 4 Paris. You can write the answer like this. Places, latitude, longitude. Mumbai 19.07 degree north, 72.87 degree east. Kolkata 22.57 degree north, 88.36 degree east. Singapore 1.35 degree north, 103.81 degree east. Paris 48.85 degree north, 2.35 degree east. Figure 1.4. This case shows how the prime meridian divides the earth into the western and eastern hemispheres, while the equator divides it into the northern and southern hemispheres. You can see Greenwich meridian or prime meridian dividing the earth vertically into western hemisphere and eastern hemisphere. Similarly, equator, also known as 0 degree latitude, divides the earth horizontally into northern hemisphere and southern hemisphere. Don't miss out. The Greenwich meridian is not the first prime meridian. There were others in the past. In fact, many centuries before Europe, India had a prime meridian of its own. Figure 1.5. Figure 1.5. The Ujjaini prime meridian used in ancient Indian astronomy. Cities marked with a circle are mentioned in astronomical texts as being on this meridian. The modern name is given after the oblique bar. You can see here 75.8 degree east longitude, also known as Ujjaini meridian. This symbol shows ancient city and this modern city. Some ancient cities are Kurukshetra, Rohitak, modern name Rohtak, Malwangara, modern name Nagar, Ujjaini, modern name Ujjain, Mahismati, modern name Maheswar, Kumari, modern name Kanyakumari. Modern cities Delhi, Mumbai, Kolkata, Bengaluru, Chennai. It was called Madhyarekha or middle line and passed through the city of Ujjaini, today Ujjain, which was a reputed center for astronomy over many centuries. Varhamihir, a famous astronomer, lived and worked there some 1500 years ago. Indian astronomers were aware of concepts of latitude and longitude, including the need for a zero or prime meridian. The Ujjaini meridian became a reference for calculations in all Indian astronomical texts. The map shows a few ancient Indian cities close to the Ujjaini meridian. Some are very close to it, while others are a little away. That is because measuring longitude required accurate timekeeping, which was not as precise then as it is today. Figure 1.6. This map, published by the Survey of India, shows the country's outline along with a few parallels of latitude and meridians of longitude. India's latitudes extend approximately from 8 degree north to 37 degree north and longitudes approximately from 68 degree east to 97 degree east. The two colors have been added. India's latitudinal extent is from 8 degree north to 37 degree north and longitudinal extent is from 68 degree east to 97 degree east. Understanding time zones. Let's make the globe rotate again from west to east. That is how our planet spins around its axis, making a full turn every 24 hours. A full turn is 360 degree, so this means 15 degree per hour, as 15 into 24 is equal to 360. Earth completes one rotation, that is 360 degree, in 24 hours. Then in 1 hour, it will rotate 360 degree upon 24. That is, in 60 minutes, Earth will rotate 15 degree. Let us now mark the meridians of longitude every 15 degree. Moving eastward from the prime meridian, we get 0 degree, 15 degree east, 30 degree east, 45 degree east, and so on every 15 degree up to 180 degree east. It is the same as adding 1 hour of local time with each meridian. If it is 12 pm or noon at Greenwich, it is 1 pm local time at 15 degree east, 2 pm at 30 degree east, and so on. But going westward, it is the other way round. 11 am local time at 15 degree west, 10 am at 30 degree west, etc. Figure 1.7. This graph shows longitudes at the bottom and the local time at the top, with reference to the prime meridian at 0 degree. Each color is a zone of 15 degree centered on a meridian. You can see 0 degree, 15 degree east, 30 degree east, 45 degree east, 15 degree west, 30 degree west, 45 degree west longitudes. Each color is a zone of 15 degree. Local time for these longitudes: 12 pm, 1 pm, 2 pm, 3 pm, 11 am, 10 am, 9 am. Let's explore. Two friends, one sitting in Porbandar, Gujarat, and the other in Tinsukia, Assam, are speaking on the phone late afternoon. The latter remarks that the sun has set in Assam and it is now dark. The former is surprised and says, "But it is still full daylight here." Explain why. And as a class activity, calculate the difference in local time between those two cities. Hint: for now, consider the difference in longitude between Porbandar and Tinsukia to be 30 degree. Later, you can find out the precise value. You can write the answers like this. The sun sets earlier in Assam than in Porbandar because of the difference in local time between the two places situated at different longitudes. Since the earth rotates from west to east, places located farther east experience sunrise and sunset earlier than those in the west. Degrees completed by the earth in one full rotation, that is 24 hours, is equal to 360 degree. Degrees completed by the earth in 1 hour is equal to 360 degree upon 24 is equal to 15 degree. Time taken by the earth to rotate 15 degree is equal to 60 minutes or 1 hour. Time taken by the earth to rotate 1 degree is equal to 60 upon 15 is equal to 4 minutes. Longitudinal difference between Porbandar and Tinsukia is equal to 30 degree. Therefore, the difference in local time between the two places is equal to 30 into 4 is equal to 120 minutes is equal to 2 hours. There is another way of thinking. 15 degree is covered in 1 hour. Then 30 degree rotation will be covered in 2 hours. The same method can be used to calculate the local time of any place on the earth, but it would not be convenient for a country to use many local times. That is why most countries adopt a standard time based on a meridian passing through them. Indian Standard Time (IST) is 5 hours 30 minutes, also noted 5.5 hours ahead of the local time at Greenwich, called Greenwich Mean Time or GMT. Indian Standard Time is 5.5 hours ahead of Greenwich Mean Time. That means 82.5° East is taken as the reference for Indian Standard Time. Let's explore. Return to the two friends sitting in Gujarat and Assam. Use this example to explain the difference between local time and standard time. You can write the answer like this. Since Gujarat lies 30° west of Assam, two friends sitting in Gujarat and Assam would notice a time difference of about 2 hours if they looked at the sun to tell the time. This is due to the difference in local time between the places located on different longitudes. However, if they checked their watches, they would see the same time. That is because India uses a standard time based on the 82.5° East meridian, which passes near Mirzapur in Uttar Pradesh. This is called Indian Standard Time or IST and is used across the entire country to avoid confusion caused by different local times. All these standard times are organized in time zones, which broadly follow the zones of 15° in the graph. Figure 1.7. But let us consider the world map below, figure 1.8. Figure 1.8, a world map of the time zones showing the standard times with respect to GMT for a few countries. Note that international borders are approximate, not exact. You can see a world map is given here showing different time zones. Countries like Canada, USA and Russia have more than one time zones. Time zones tend to align themselves along national and international borders to avoid confusion created by different local times. You can see prime meridian here, also known as Greenwich meridian, whose local time is known as Greenwich Mean Time. All countries located in the east of prime meridian having positive numbers written on them. To find their standard times, you have to add these numbers. Similarly, all the countries located in the west of prime meridian have negative numbers written on them. To find their standard times, you have to subtract these numbers. You can see at approximately 180° longitude, there is a zigzag line known as international date line. When you cross it, you have to change the date in your watch. We can see that the lines dividing the time zones are not fully straight. This is because they have to respect each country's standard time and therefore tend to follow international borders. The numbers written inside some countries are the numbers of hours to be added to GMT to get their standard times if they have a positive sign, or subtracted from GMT if they have a negative sign. Don't miss out. From the above explanation, it may seem as if every country has one standard time. That is not always the case. Some countries like Russia, Canada or the USA are too large to have a single time zone. The USA has 6 time zones and Russia has 11, which means that traveling across Russia from east to west, you will need to readjust your watch 10 times to align with the local time. Similarly, the globe in figure 1.9 centered on India shows standard time with respect to GMT for a few countries. Figure 1.9 a few time zones with respect to GMT in Africa and Eurasia. Finally, while the prime meridian was fixed at Greenwich, the opposite line at approximately 180° longitude is called the international date line. As you can see on the map, the plus 12 and the minus 12 time zones touch each other at this line. If you cross it by ship or plane, you need to change the date in your watch. If you cross it traveling eastward, you subtract a day, say from Monday to Sunday. If you cross it traveling westward, you add a day from Sunday to Monday. We said that the international date line is approximately at 180° longitude, as it deviates in places to avoid dividing some countries into two different days. Before we move on, maps are very useful tool to represent an area of the earth, whether small or large. The main components of maps are distance, direction and symbols. Every place on the earth has a location which can be precisely defined with the help of a grid of latitude and longitudes. Imaginary lines running from east to west parallel to the equator and north to south from pole to pole respectively. Longitude also marks the time and defines the time zones. The international date line is located approximately at 180° longitude, opposite to the prime meridian. Crossing the international date line changes the date by 1 day. Questions, activities and projects. 1. Returning to page 10 and to figure 5.2 in chapter 5 of this textbook, taking the scale to be 2.5 cm is equal to 500 km. Calculate the real distance from the estuary of the Narmada river to the estuary of the Ganga river. Estuary, the place where a river meets the sea. Let's move to chapter 5 and see figure 5.2. You know the scale is 2.5 cm is equal to 500 kilometers, or 1 centimeter is equal to 500 upon 2.5 kilometers, or 1 centimeter is equal to 200 kilometers. You have to find the actual distance between the estuary of the Narmada river, that is from this point, to the estuary of the river Ganga, that is to this point. The approximate distance between these two estuaries is 10 cm on the map. Since the scale is 1 cm is equal to 200 km on the ground, thus 10 cm distance on the map will be equal to 2000 kilometers on the ground. The answer will be 2000 kilometers. You can write the answers like this. Distance between the estuary of Narmada river to the estuary of the Ganga river represented on the map is equal to 10 cm. Actual distance between the two places on the ground is equal to measured distance in centimeter upon scale in centimeter into real distance in kilometer. That is 10 upon 2.5 into 500 is equal to 4 into 500 is equal to 2000 kilometers. Let's move to chapter 1. Two. Why it is 5:30 p.m. in India when it is 12 p.m. or noon in London? You can write the answer like this. India, located at 82.5 degree east longitude, lies to the east of the prime meridian in Greenwich, London. Indian Standard Time (IST) is based on this longitude and is 5 hours 30 minutes ahead of Greenwich Mean Time or GMT. Therefore, when it is 12 pm in London, it is 5:30 pm in India. 3. Why do we need symbols and colors in the map? Answer. Symbols and colors help represent features like buildings, roads, bridges, forests, railway lines, and water bodies effectively on map. They convey a lot of information in a limited space, making the map easier to draw and simpler to read. 4. Find out what you have in the 8 directions from your home or school. You can try doing that. For your help, the answer can be written like this. Directions from my home: north, residential houses; northwest, school; northeast, tube well; east, college; west, tube well; southwest, banquet resort; southeast, agricultural land; south, power station. 5. What is the difference between local time and standard time? Discuss it in groups, with each group writing an answer in 100 to 150 words. Compare the answers. A sample answer is given here. Local time refers to the time of a place based on the position of the sun in the sky at a particular longitude. When the sun is at its highest point at the prime meridian in Greenwich, all places along this meridian experience midday. As the earth rotates west to east, places lying east of Greenwich are ahead of Greenwich Mean Time or GMT, while those to the west are behind it. For a country spanning multiple longitude, it is quite inconvenient to use many local times. To overcome this, the local time of a central meridian is taken as the standard time for the whole country. In India, the longitude 82.5 degree east is taken as the standard meridian and the local time at this meridian is observed as the Indian Standard Time or IST across the entire nation. 6. Delhi's and Bengaluru's latitudes are 29 degree north and 13 degree north. Their longitudes are almost the same, 77 degree east. How much will be the difference in local time between the two cities? You can write the answer like this. Longitudes help us determine the local time of a place, and places lying on different meridians have different local times. Since Delhi and Bengaluru are located on nearly the same longitude, they will have the same local time. 7. Mark the following statements as true or false. Explain your answers with a sentence or two. All parallels of latitudes have the same length. This statement is false. Explanation. The equator is the longest line of latitude, and the lengths of latitudes decrease as we move away from the equator toward the poles. The length of a meridian of longitude is half of that of the equator. This statement is true. Explanation. The equator is the longest horizontal circle around the earth, while meridians are vertical half circles that connect the north and south poles. This makes the half the length of the equator. I am considering this statement as true because I am considering Earth as a complete sphere. But in reality, Earth is not a complete sphere. It has flat poles. Earth is said to be geoid in shape. The South Pole has a latitude of 90 degrees south. This statement is true. Explanation: the South Pole lies at 90 degrees south of the equator. In Assam, the local time and the IST are identical. This statement is false. Explanation: IST remains the same throughout the country, while the local time in Assam depends on the longitude passing through it. Lines separating the time zones are identical with meridians of longitude. This statement is false. The lines dividing time zones are often adjusted for political reasons and do not follow straight meridians of longitude. The equator is also parallel of latitude. This statement is true. Explanation: the equator is the longest parallel of latitude located at 0 degree and it divides the earth into the northern and southern hemisphere. 8. Solve the crossword below. Locating places on the earth. Directions given here for across and down. 1. Lets you squeeze a huge area into your map. Scale. 4. A convenient sphere. Globe. 5. The longest parallel of latitude. Equator. 6. The place the prime meridian is attached to. Greenwich. 8. So convenient to find your way. Map. 10. A measure of the distance from the equator. Latitude. 2. A measure of the distance from the prime meridian. Longitude. 3. These two together allow us to locate a place. Coordinates. 6. What latitudes and longitudes together create. Grid. 7. The time we all follow in India. IST. 9. On top of the world. Pole. 11. An abbreviation for a line across which the day and date change. IDL. For more videos, you can like and subscribe @NCERT video book. Thank you.